So this week's lesson has to deal with the empirical rule, which is um, happens to deal with a distribution of data. So, excuse me. What we have to understand is uh, there are certain things. We've calculated mean, we've calculated other things, we've calculated standard deviations, right? So this is X bar, which is the mean, right, of your data set. Um, and each one of this would be +1 standard deviation. This would be +2 standard deviations. And this would be +3 standard deviations. Of course, the other one would be what? Negative 1 standard deviation, right? -2, and then -3. Okay, so what you have to actually understand is 1 standard deviation to the left and to the right of your mean, if it's a normal distribution. Meaning, what is a normal distribution? Is that it's the bell-shaped curve, right? So that's really the only. We're not going to look at skewed left, skewed right, or any of that other stuff. We'll just look at a normal distribution. So what we have to understand is 1 standard deviation to the right and left of the mean is 68% of your data falls within 1 standard deviation. Okay. If you go to 2 standard deviations away from the mean, then what you are looking at, and boy, I do it like this. What you're looking at is 95% of your data is within 2 standard deviations. That means 2 to the right and 2 to the left. That much is 95% of your data. Okay. Now, if you were to go 3 standard deviations above and below your mean, then what you're covering is, that what you're looking at is actually 99.7% of your data, right? So you've got to make sure you understand that within 3 standard deviations plus minus of your mean, 99.7% of your data is within that. Okay, so that's what the empirical rule does. So what I'm asking you to do is go back here. Let me go to dashboard. Go to dashboard. There we go. And if you're looking at today's thing, I don't know why those are showing up. Oh, I do, because they won't show up on yours. They just show up on mine. All right. So what I've asked for you to do is called 420 Monday empirical rule. There's 2 things. There's a video that explains exactly what I just said, right? And here's some definitions of stuff. Um, they talk about vocabulary. It gives you more background information, okay? Um, and it's pretty good. So I would read that plus watch that video. But your main thing that you're going to get into is you only have five problems for the empirical rule, because I want you to be able to put things in place. Like for this one, uh, according to national testing data, college math testing times are normally with a mean of 42 and a standard deviation of 2 minutes, right? Okay. So the bell curve below represents the probability distribution for testing times. On the scale, the horizontal is equal to standard deviations. Okay. So this one would be what? It would be your mean, right? 42. And then this would be 1 standard deviation. This would be 2 standard deviations, right? So this one would be 2 plus 2, which would be 4, which should be 46, right? And then if we go 4 below, that should be at what? 38, right? So if we hit that, unless those boxes are in the wrong place, that's kind of what we're doing. We're having you understand, okay, where's things at and what is its values, right? Okay. So when they say, hey, standard deviation, we calculated that last week, right? What is the purpose of standard deviation? Well, standard deviation can tell you a lot from the mean of your um, from your data set. And what you have to understand is that when we do this, and because we're looking at a normal distribution, a bell-shaped curve, excuse me, what we are actually doing is we're saying that the mean, the median, the mode are all right there, right? That they're the mean, okay? When you have a bell-shaped curve. So that's just some theoretical stuff. But I mean, you're gonna have so that's the first one. Um, the second one is this. They giving you the standard deviation. I mean, the mean, which would go in here, right? So what would this value? What would the numerical value be if it was 1 standard deviation, 2 standard deviations, 3 away from the mean? So that's what they're doing on this one, right? So for this one, you're looking at, well, the mean is 41, right? All right. If the standard deviation is 3, then 3 above and 3 below, right, would be 1 plus or minus that, right? You're looking at 68% of our data being between 44 and 38. Okay, 68% of our data would be between that. Okay. Now, if we were to go another 3 below that, that would be at 35. And then this would be at 32, right? This would be at 47, and this would be at 50. All right. So we'll make sure we're okay. So everything's correct. But I want you to see something. Between the value set, between 38 to 44, okay, but that range is 68% of our data. Okay. If we say 35 to 47, well, that holds 90% of my data right there. And if I were to go 32 to 50, then I'm at 99.7% of my data, right? Okay. So that's 99.7% of something. Okay, I'm good with that, right? Does that make sense? So that's what you got to understand. Between 32 and 50, 99.7% of the data falls, right? But between 35 and 47, 2 standard deviations to the left and 2 standard deviations to the right of this mean, right? This mean right here. See, that's -1. That's +1. This would be -2. And that would be what? +2 standard deviations. So we're looking at things of the first day, the empirical rule. Okay, how do we read a bell-shaped curve? How do we understand standard deviations, adding and subtracting, all that other stuff, right? Because that's what we're doing. All right. So there's only 5 problems. All right. So not a tremendous amount of work. Um, but what I want to leave you with is this. Um, we are going to, well, let me back it up. Let me go back to here. Let me move this back down. What if this is where we're going tomorrow, and this is why we're going tomorrow. See, it's all great if our numbers fail on perfect standard deviations, right? 1, 2, or 3 above, or 1, 2, or 3 below the mean, right? That'd be great. Our life would be so easy. But what we're going to be end up doing tomorrow is we're going to find out what do we do if it doesn't fall on a perfect standard deviation, like 1, 2, or 3, or -1, -2, or -3. What are our options? Well, what we're going to do is we're going to find what's called a z-score. Okay, and that z-score is going to give us a value that we need to be able to find out what it would be. Okay, so that's where we're heading to. There's already 2 videos up on that. I really, really, really like the first one. Um, it's a guy. He pronounces his Z's kind of strangely. Um, he's just from another country. So, but anyway, I say from another country. His pronunciation of Z's is a little bit different, but I love his content. He is straight on. It is top notch what he's doing. And he works 3 examples really quickly, and he shows you how to use Z tables, right? And that stuff is what you're going to have to make sure you watch and do before we talk tomorrow at 1 o'clock. Okay. Yeah, because those are going to help you. The 2 videos tomorrow, they're going to give you something. See, if you don't write it down, then all you're doing is looking at it, right? And that's only like 30 to 40% retention. If you write it down and understand where things are coming from and all this stuff, when you go to work another problem, you have something to attach it to or pull from, right? The more you do, the more you have to attach your learning to, and the more that you have to bring forward. So you got to make sure you do that. So today's ought to be really, really easy, right? And you could actually go ahead and get started on tomorrow's watching those videos. And and that's going to be it. Z-scores and finding Z-scores going to help us find the probability for the area underneath the curve to find the probability of something happening, right? And that's it. We're done. And then next week we will be reviewing for the Unit 7 test. Um, and you'll have a practice review, right? Just like we normally have. And then uh, we're done with content. Now, if you have done everything that uh, everything that I've assigned, and you are okay with your grade, then all you have to do is consider whether you want to do any enrichment stuff. And I'll have some enrichment activities out there. You don't have to do them. It's strictly up to you. They're not penalized against you. So those of y'all that are done are going to be like, hey, I can work on some things to get my grade up, right? If I want to, I'm done with everything. I'm not missing any assignments. But if I am missing assignments, if I am missing stuff, then what you're going to go into is called a remediation group, which you will be having certain days that you have to finish certain things so that we get this all done. So my focus will be on the people that haven't completed work, like missing quizzes, missing homework, stuff like that. Um, and then once we get that all done, and they say, "Hey, we're done," we're done. Okay. So for the people that's got everything done and they're satisfied with their grade, they don't have any opportunities to make it get higher per se. Then we'll you're done. You're done with math. So basically, after the end of next week, you'd be done with not college algebra, pre-calc, right? So, but there you go. If once or not, then they're going to be doing more work as we progress along. So there. But that's kind of how everything is in a nutshell. All right. So do these 4 or 5 problems. Watch the videos. Do the 4 or 5 problems. Take notes. Go ahead and get started on tomorrow's, because that's going to make so much more sense to you. You're going to build on that. Know how to do Z-scores. There's a PDF there. Print it out or save it to your computer. Have it accessible because you're going to use that. Okay. All right. Any questions? I mean,